Let's have an example of Bayes' theorem. According to Arizona chapter of U.S. Lung Association, 7% of the population has lung disease. Of those with lung disease, 90% are smokers. Of those not having lung disease, 74.7% are non-smokers. What is the probability that a smoker has a lung disease? Pause the video and try to see if you'll be able to answer this one out. Alright, so let's see what information we have. We know that 7% of the population has lung disease. So, the probability that there's a lung disease, I'll let that as event L, is equal to 7%. Of those with lung disease, 90% are smokers. So that meant that the probability that the person is a smoker, given that that person has lung disease, is 90%. Pretty high. Well, those without lung disease, 74.7% are non-smokers. So that meant that the probability that you are a non-smoker, given that you do not have lung disease, is around 74.7%. 74.7%. We are now asked what is the probability that a smoker has lung disease. So that meant we are now asked what's the probability of that person having a lung disease given that that person is already a smoker. Now, let's try to illustrate this information that we have. So it's time again to draw our, there you go, for easy illustration. And we have the probability that a person has lung disease is just 7%. So that is quite low. So the one with lung disease is probably just around, let me illustrate it like this. This one here, and then another one there. So this is our 7%. So the probability that we have a lung disease is 7%. Of those with lung disease, 90% are smokers. So that meant that around this much here are smokers, the one in that blue line there. So this one here now would be the probability, this one here now would be the probability, or the event rather, that a person has a lung disease and is a smoker. The probability that has a lung disease and a smoker. And that would be equal to 7% times the probability of being a smoker given that his lung disease, which is 90%. There you go, and that would be equal to 6.3%. 6.3%. So this already is our numerator in our formula. So the rest, those without lung disease, I'm going to have them as L complement, is actually a 93%. Because, well, those with lung disease is 7%. And we are told that of this 93%, 74.7% do not have, or are not smokers rather. So that would mean, let's illustrate that 74.7%. I'll just be using this one here. Then, just a very rough estimate. Just have it like this. There you go. So there. So we have here that of this 93%, the non-smokers would be 74.7% of our 93%. Of our 93%. And that will give us around 69.47% here. This is 69.47%. While here, those that are smokers but without lung disease would actually be, since this is the complement already, so to get the percentage here, that would be 1 minus 74.7%, and you multiply that to your 93%, and this will actually give us a result of 23.53%. 23.53% here. And as we know, this area here is the probability already. This area is the probability that the person is a smoker given, this color, given that that person doesn't have lung disease, which is what we actually need. These two areas here. So, our probability would be, let's pull that down there, the probability that the person has lung disease given that person is a smoker is actually this probability, that's 6.3% out of the total number of probabilities of those people smoking, which would be our 6.3% plus our 23.53%, which will give us around 20, let's fix that, around 21.52%. So there's a 21.52% chance that a person will have a lung disease given that that person is actually a smoker. Now, if we're going to apply the definition of Bayes' theorem in formula, that would be equal to, there you go, the 7% times our 90% here, times our 90%, all over the same number, 7%, let's change that to its original color, there you go, the 7% times the 90% plus our L complement here, which is our 93%, multiplied to this one here, 1 minus 74.7%, which is actually 25.3%. 25.3%. Now, let's put again our definition or our formal formula of Bayes' theorem here. There you go. We have here our formal definition of probability. And like what we mentioned a while ago, this is the difficult one. How do we get the probability of a person being a smoker given that that person doesn't have lung disease? But what we know is the probability that the person doesn't have, or it's not a smoker rather, and doesn't have lung disease. This is where our illustration provided us an information that this is the complement of the probability that a person is a smoker given that that person doesn't have lung disease. So based on this perspective, based on our illustration, we were able to find this value right here. Therefore, the probability of a person having lung disease given that that person is a smoker is 21.52%. That's an example of Bayes' theorem.